let's just jump right into it. We've already covered the basic ideas. Now we're going to get to more realistic problems, what you actually might see. So for instance, you might be given an inequality that looks like this. -1 greater than 2x minus 5 greater than -9. Now what you're trying to do is solve this inequality for the range of variables that we will then graph on the number line that satisfies this compound inequality. And notice, because it's written with the double arrows like this, you read it from the inside out. 2x minus 5 is less than -1, and 2x minus 5 is greater than -9. You read it from the inside out, but because it's written as a double arrowhead like this, you automatically know that this is an and type of situation. So when you can expect that whenever you plot it, eventually when we find the solution, it will form a line segment on the number line. You might have a closed end or an open end depending on what the problem is. In this case, we're going to have open circles, but it will form a line segment between two values on the number line. So because you know it's and, the next thing you do is you go in and read it from the inside out, and you have to write two separate inequalities joined with that and. So you read it from the inside out. 2x minus 5, the arrow points towards the 2x like this, or towards this term I should say. So it's less than -1. Make sure you understand this less than -1, this less than -1. I've just kind of rearranged it in the typical way that we would write it. And then you literally write the word and, if you can spell the word and, right? So and. You write the second inequality just the way it sits. So 2x minus 5 greater than -9. So you've taken your single problem, which really is two problems rolled together, and you have now branched it into two separate inequalities joined with an and. And we just solve them. So let's move the -5 over here by adding 5. So you get 2x less than, you'll have -1 plus 5. So you will have 2x less than, what do you do when you add -1 plus 5? You get 4. And then finally, x is going to be less than 4 over 2 because you divide 2 on the side, getting rid of the 2, divide by 2 over here. So you get x less than 2. You get x less than 2 over here. And then you can go on the other side, and I can switch colors to try to make this a little bit easier to follow. On the other side, we're going to move this 5 over by, again, adding 5. So it'd be 2x greater than -9 plus 5, right? We add 5 to the left, making it go away. We add 5 to the right, and we get 2x greater than, what do we get when we add these? We get -4. All right? So then to get x by itself, we divide by 2. So it'd be -4 divided by 2. So we get x greater than, what do we get here? -2. 4 divided by 2 is 2, and so on. Negative divided by positive is negative. So ultimately, we have now, and this is very important for you to realize, that both of these inequalities, this one that we solved from this one, and this guy here that we got by solving the other one, they are joined together with an and. That means the solution set for this original inequality has to satisfy this one, x less than 2, and also this one, x greater than -2. So if you want to go up here and plot it, x less than 2 with an open circle would be, here's an open circle, it would be all values less than 2, but at the same time, the x values have to be greater than -2 with an open circle. So the only way they both can be true at the same time is if this is the right segment on the values there, not including -2, not including +2, but all of the values between would be less than 2, but at the same time being bigger than -2. And since we have two inequalities joined by an and in our final solution, we can represent it in our double arrow notation. Just write your x, go ahead and write a less than, or you can, depending on how you read it, I call it a less than symbol, but the way you read it is x greater than what? X greater than -2, so the -2 goes over here. X less than goes with this one, x less than 2. So this is how you would write the answer. So on an exam, if you were told to solve this compound inequality, the answer you would circle was this: x is greater than -2, x is also and less than 2, and you would plot it on the number line exactly the way that we've done it right there. So all of the problems are going to kind of work like that. If you have an and type of inequality, you'll break it up into two pieces, solve them, plot them, and maybe rejoin them in the double arrowhead, in the double inequality notation, as we've been doing. Now for our next problem, let's say we have 2z, we're just using a different variable, but it's exactly the same sort of deal, -1, less than or equal to 5, and then you have the word or, 3z minus 5 is greater than 10. So now, you know, we don't have an and here, we have two inequalities joined with an or. And so you know right away, because it's joined with an or, that it's not going to look like a line segment like we have on the other one. It's going to look like two parts of the number line going away from each other with values to the left and values to the right. That's what or type of compound inequalities look like. So what we'll do is we'll solve this guy separately from this guy. We'll move the 1 over here by adding it. So it'll be 2z less than or equal to add 1, get this, add 1 to 5, and you get 6. And then to get z by himself, we divide by 2, like this. And so then z less than or equal to 3. That's the first part. And then, of course, this big fat or here, don't forget that. And then we'll switch colors, and we will solve the right-hand inequality right here by moving the 5. So we get 3z. We'll add 5 here, so we'll add 5 here and get 15. And then to get z by itself, we'll divide by 3. So 15 over 3. So z will be greater than what's 15 divided by 3 is 5. So here you have a less than or equals to sign because it comes from the problem statement. And here you just have a greater than sign in the answer because that's what comes from the problem statement. So this is what you would circle on your exam as the final answer. Z has to be less than or equal to 3, or z can be greater than 5. So let's go up here and see if we can understand it a little bit more by plotting it. Less than or equal to 3 means that I'm going to have a solid circle at 3, all values less than 3, or greater than 5. That means an open circle at 5, off to the right, greater than. And to see exactly everything that we predicted ahead of time came true. It's an or type of inequality, so we're going to get two guys that are going to be separated by an or, two inequalities separated by an or. And on the number line, it'll look like two parts of the number line shaded going in opposite directions from the points that you found there. And of course, sometimes it can be open and sometimes it can be closed circled depending on what you were given in your problem. But in general, that's going to be how we do all of these problems. Ands are going to look like segments, and ors are going to look like going in opposite directions. So now what we're going to do is we're going to solve the rest of the problems, circle the solutions, and we'll kind of go back here and we'll graph them just to get some practice with that as well. So the next problem is 2 times t plus 7 greater than or equal to 13, or 5 times t minus 4 is less than 6. So right away, we know it's an or, so we know we're going to get two answers separated by an or, and we know in the number line, they're going to be shaded regions that go away from each other. So we'll take a look at this one. We're going to take the 7 and move it by subtracting 7. So you get 2t greater than or equal. Subtract 7 here, you get 0. Subtract 7 here, what do you get? You get 6. 13 minus 7 is 6. Next step, we're going to isolate t by saying it's 6 over 2, dividing both sides by 2, which means t is going to be greater than or equal to 3. And then, of course, we'll have the or. And then over here, just to try to separate it, we'll switch colors. And we'll move the 4 over by adding it. So we'll have 5t less than, what is 6 plus 4 is 10. We add 4 here, getting 0, add 4 here, getting 10. And then t is less than or equal to 10 over 5. Just divide both sides by 5. T is less than or equal to 2. All right, actually it's not equal to, sorry, there's a no equal to sign over here. So we have an equal sign underneath the inequality here, but we don't have them on this side. So greater than or equal to 3, less than 2, and then this is going to be our final answer. Now if we're going to plot it, we're basically saying greater than or equal to 3, so we have a closed circle here, greater than or equal to 3, and we also say less than 2 or less than 2. So it'll be an open circle because it doesn't include the number 2, and it'll be everything less than here. So if it's an or inequality, it means the points can be over here or over here, but they don't have any overlap, so of course it can't be both at the same time. And that's the final answer. Let's do another and inequality. Let's say we have 2 times t plus 7 greater than or equal to 13, and 5t minus 4 is less than 6. So we know it's an and. We know we're going to have a double arrow-headed answer with everything being able to written in the double inequality type of notation. And we also know that it'll form a line segment if once we graph the final solution, because that's what the ands look like. So what we'll do is we'll solve this guy by moving the 7 to the other side by subtraction. So it'll be 2t greater than or equal to 13 minus 7 is going to be 6. 13, you subtract 7 from both sides, give you 6. T is greater than or equal to 6 over 2. So t is greater than or equal to 3. And you have the word and here. And then on the other side, we're going to move the 4 by addition. So we'll have 5t less than, so what is 6 plus 4? It's 10. Because we just add 4 here, and then we have t less than 10 over 5, and then we have t less than 2. So this is the answer that you could circle it. I guess I'll leave it off because there's another way to write this. We're basically saying is t is greater than or equal to 3 and t is less than 2. So before we try to write it as a double arrowhead kind of deal, which is typically what we'll try to do at the end, is let's go try to graph this guy. Greater than or equal to 3, so we'll have a dot here at 3, and it would be the numbers greater than 3, and t is less than 2, which is this one. So what we're saying is the solution set of these inequalities has to be greater than or equal to 3, which means you would have, if I continue here, I would have the dot here and all the numbers here, and also numbers less than 2, which means this segment over here. It is impossible to satisfy this inequality at the same time that you're satisfying that one. It's impossible to pick a number that's bigger than 3 and less than 2 at the same time. It just can't happen. So when you get down to the step, you try to see if it can be satisfied, and you look at the number line, you realize you cannot be over here at the same time that you're over here as far as a number goes. So what you really write down is there is no solution. No solution to this inequality. And that's actually the answer. So I'm going to erase these because this really isn't true. I put it up there to kind of show you the logic behind it. But if you look back to all of our other examples, like let's look back to this first one. We solve this guy, and the very next step is, okay, can we satisfy both of these? Yes, we can be less than 2 and bigger than -2 at the same time. Yes, that works. At the same time, yes. Can we be less than 3 or bigger than 5? Yeah, we can be less than 3 or bigger than 5. That makes sense. So we graph it. But once we get to this one, can we be bigger than 3 or less than 2? Can we be bigger than 3 or less than 2? Yeah, we can pick one of those. Sure we can. And then we have this and. Can we be bigger than 3 at the same time that we're less than 2? It's not possible. You can't be bigger than 3 and less than 2 at the same time. So it's important when you get down to the point where you solve each of them to look at them and say, is it possible for me to find a set of numbers that satisfies both of them? And in this case, even though it's an and, it has no solution. Just like some later on, we'll get to systems of equations. They won't have solutions either. Sometimes they just don't. Some equations don't. Some inequalities don't. All right, we have a couple more. What if I gave you a problem that looked like this? -5 less than 1 minus 2x less than 3. And I said, solve this compound inequality. Well, before doing this lesson or the last lesson, you might look at that and be worried about it. But now you see, okay, I have something in the middle, right? And I have the double inequality notation. So I know that it's an and type of inequality. So if it does have a solution, it'll be a line segment of some kind on the number line. So the next step is to write it as such. So read it inside out. So we have 1 minus 2x greater than -5. You literally read it this direction. So the big part of the inequality goes here, the -5. And then you have and, of course. Both of them have to be true. 1 minus 2x less than 3. And then we solve both of them. So we move the 1 over here by doing what? By subtracting 1. -5 minus 1 is -6, right? And then what do we have over here? We divide by -2. So let's divide by -2. X greater than, actually, you realize, wait a second, I'm going to be dividing by a negative. So when I divide by a negative, I have to flip the direction of that inequality. -6 divided by -2. So x is actually less than +3. X is less than +3. So this is one half of the solution. And the other half we still have to solve. So let's go over here and solve it. Let's subtract 1 over here. So you'll get -2x less than. -1 gives you 0. 3 minus 1 gives you 2. Now we have to divide by a negative. So the same sort of thing happens. We flip the direction of the inequality. 2 over -2. So once we do that division, the inequality flips. X is greater than -1 because the division is going to give you a negative sign. X is greater than -1. So we have x is less than 3 and x is greater than -1. So let's plot it and see if it's possible, just like we've been saying. X less than 3, but not equal to, so we'll put an open circle there. X greater than -1. -1 is way over here. Is it possible to be less than 3 at the same time that you're greater than -1? Yes, but only for these values that lie in between. So it does form a line segment, open, segments there. And because the solution's valid and we convince ourselves that we do have a solution set, then we just kind of write it in our compact notation by putting x in the middle, putting our double arrowheads or our double inequalities in place, and we say x is greater than, this is greater than, -1. X is less than, that applies to this one, 3. This is how you would write it. X is greater than -1, that corresponds to this. X is less than 3, that corresponds to this. And then, of course, we've already plotted it over here. So it's not rocket science, but it does have a little parts we got to be careful about. We have to worry about flipping the sign here. We have to worry about writing it in the correct notation. We have to worry about plotting it on the board. All right. This will be our last problem in this lesson. What if we have -3 less than 2 minus y over 3 less than or equal to -1? So again, it's written with a double inequality type of notation, so you know it's going to be an and, so you can go ahead and write that to yourself, just to remember, just to kind of make sure that you don't forget that. And because it's basically two inequalities wrapped up in one, the first thing we're going to do is rewrite them. This goes over here, so 2 minus y over 3. It's written with a reading from this direction out, greater than -3, and the inside again, 2 minus y over 3, less than or equal to -1. So you read inside out to get this one, inside out to get that one, joined with an and. And the next thing we do is just solve each side separately. So we're going to subtract 2 from both sides. That's going to give me -y over 3 greater than, when you subtract 2 here, you get 0. -3 minus 2 will be -5 on this side. So we subtract 2 from here, subtract 2 from here. Now you have to do a little bit of thinking. All right, because what you have is you have a negative sign here, y over 3. Obviously, you want the negative sign to be gone next to your y, and you want the 3 on the bottom to be gone. So there's a couple of ways you can do it. This is the way I'm going to tell you to do it. Let's rewrite this so we don't kind of destroy what we have. -y over 3 greater than -5. What I would like to do, I can do anything I want to both sides. So I'm going to multiply the left-hand side by what? By -3 over 1, or basically -3. And when I do that, I also then have to multiply the right-hand side by -3 over 1, which is just multiplying both sides by -3. But because I multiplied both sides by a negative number, I have to remember to flip the direction of that inequality. You have to remember to do that. So now it goes this way. It goes the exact opposite. This negative will multiply to this, give me positive. The 3 will cancel with the 3, so I'll have y less than positive, negative times negative gives you positive 15. So you get y is less than 15. That's 1/2 of the answer. And then we have to go over here and then solve this inequality to get the other half. So subtracting 2 from both sides, you get -y over 3 less than or equal to. Subtract 2 here, get 0. Subtract 2 here, you get -3. Right? So let me rewrite it again. -y over 3 less than or equal to -3. And now I can do anything I want to both sides. So to kill the negative sign and also kill the 3 in the bottom, I'm going to multiply this by -3 on the left and multiply by -3 on the right. This gives me a positive, and also the 3 cancels with 3. So what I will have for a final answer over here, only a y will remain on the left. I'll have less than, actually what you have to do here, at the moment you do that multiplication, because I multiplied by a negative, this sign has to be flipped around. Don't forget to do that. You flip it around the other direction, so you will have greater than or equal to, 3 times 3 is 9, negative times negative gives you positive, so you get y greater than or equal to 9. So then you have this, don't forget, joined by an and. So then you see, is it possible, okay? Can y be less than 15 at the same time that it's greater than 9? Less than 15, greater than 9. Is that possible? And the answer is yes, it is possible. So let's go and first look at the less than 15 part. We're going to go over here and use one of these that we haven't done in a while. And what we will do, let's just make it easy. We're going to have to erase a little bit of these things here. So what we will do, it doesn't really matter so much the tick marks. So let's just go ahead and say 0 here. Let's just say that this is 9 units away, and this is like 15 away here. I know the tick marks aren't exactly quite right, spaced properly, but that's okay. Somewhere to the right of 0 will be 9. Somewhere to the right of 0 will be 15. So what we're saying with the answer to our problem is it's going to be less than 15, but greater than or equal to 9. So less than 15 means open circle here. Greater than or equal to positive 9 means it's going to be greater than this number, but less than this number. And if I had different tick marks, or if I moved 0 over here and drew the whole number line out with numbers, then it would, it would match up exactly. But you know that somewhere to the right of 0 is 9, somewhere to the right of 0 is 15, and between those is where we have our solution. Now there's one final step. Once you get to the point where you believe that this is a true solution, that you can form that, is you go ahead and write it as a compound, kind of double inequality notation. Write your variable with 2 less than signs. Of course, we got to double check ourselves. So what we have is y is greater than equal to 9. Y is less than, right here, 15. So all you do is you go back and you write it like that. Let me double check. Y is greater than or equal to 9, less than 15, and make sure that when you write it like this, it matches what you got before. So essentially, that's how you do all of these compound inequality problems. If it's written with an and, you have 2 inequalities to solve. If it's written with an or, you still have 2 inequalities to solve, but the way that you join them in their final answer will look a little different in the number line. And also, only if it's an and are you able to write it in this compound notation here, where you read from the inside out. So make sure you can do all of these, solve them all yourself. Follow me on to the next lesson. We'll get a little more practice with solving compound inequalities. Learn anything at mathandscience.com.